This presentation speaks to how a heat pump operates. A heat pump is an efficient method of utilizing energy, as most operate on a 300 to 400% efficiency rating. This means they can supply 3 to 4 times the amount of heating or cooling for the amount of electricity used. There are many different types and applications, but those which are commonly used in building applications are presented here. The heat pump is a mechanical device which transfers energy from one medium to another. The device can provide heating or cooling upon demand. A refrigerator is a good example of a one-stage device, as it removes heat from the food in the refrigerator and delivers it to outside the refrigerator. There are 4 heat pump requirements: a source of heat and a method of extracting the heat during the heat cycle, a source of heat removal, and a method of removing the heat during the cooling cycle, a fluid to move the heat from the source to the individual device, a pump system to distribute the fluid. In buildings, it is usual that low-temperature boilers act as the heat source, and roof-mounted dry coolers provide the heat removal for heat pump operation. Circulating pumps circulate the heating or cooling water. The main components of a heat pump are evaporator, compressor, condenser, expansion valve, reversing valve, supply air fan, and filters. A wall-mounted programmable thermostat cooling cycle. The evaporator removes heat from the supply air that the supply fan is moving through it. The combination of liquid and vapor which enters the coil is converted to a vapor on the leaving side of the coil. Compressor. The compressor compresses the low-pressure vapor into a higher pressure, high-temperature vapor and delivers it to the condenser. The condenser removes heat from the high-pressure, high-temperature vapor and delivers a liquid to the inlet of the expansion valve. The expansion valve allows the condenser liquid to change to a liquid plus vapor before entering the evaporator coil. Supply air fan. The heat pump operation is such that a supply air fan blows warm air across the evaporator coil and supplies cool air to the conditioned space. The filters clean the return air and protect the evaporator coil from dirt buildup. Heating cycle reversing valve. The reversing valve allows for the direction of flow of the refrigerant to be changed or reversed upon demand, allowing heat to be moved in either direction of the 2-stage heat pump. Evaporator. The evaporator in effect becomes the condenser coil and adds heat to the air that the supply fan is moving through it. The condenser in effect becomes the evaporator coil. Supply air fan. The supply air fan blows cold air across the evaporator coil, which is now effectively the condenser coil, and supplies warm air to the conditioned space. Filters clean the return air and protect the evaporator coil from dirt buildup. Wall-mounted programmable thermostat. The thermostat will have a fan operation selection capability. When on is selected, the supply fan will operate continuously, providing constant airflow and constant air filtering. When auto is selected, the supply fan will operate only on a demand for heating or on a demand for cooling. The thermostat will have a heat pump, auto, heat, cool, temperature, control selection switch. When auto is selected, the heat pump will provide heating or cooling on demand. When heat is selected, only the heating cycle can be operated on demand. When cool is selected, only the cooling cycle can be operated on demand. I hope this helps you understand how a heat pump works. Take care now. Bye.